Okay, so now that we have developed what the derivative is, we introduced the notation f prime. We want to look at some problems where we want to find the derivative. So f of x equals 3x minus 7. F of x equals 3x minus 7 is the first example we want to look for. Now, I realize some of you may have had some background in calculus before this, and you learn about shortcut rules. We are going to get to those. But for now, we want to focus on using this limit definition and what we can get from it. And there's a couple of benefits to that. One is the algebra practice. Later on, we're going to be doing derivatives without this limit rule, using shortcut, if you want to call them that, rules. But we're going to be involved with a lot of algebraic simplification that we have to do. And so here, it's a good chance to get some practice in with that. And also, we're strictly using the definition, and there is some appreciation for how that works. So let's consider this problem here. F of x equals 3x minus 7. Once again, remember the derivative formula is the limit as h goes to 0 of f of x plus h minus f of x, all that divided by h. All that divided by h. So we need to evaluate. So we go ahead and we do limit as h goes to 0. And when it comes to f of x plus h, we have to go into that 3x minus 7 function and plug in x plus h everywhere we see a variable. So that will give us 3x, 3 times the quantity x plus h, minus 7, and then that's minus f of x. F of x again is 3x minus 7, so minus 3x minus 7, and then all over h. All over h. At this point, we're set up and ready to start working things out. So in the top, we can distribute through by a 3 with the x plus h, and we can distribute the minus sign through that quantity 3x minus 7. So the limit as h goes to 0, that would become 3 times x plus 3 times h, so 3x plus 3h, minus 7 still, and then distributing the negative sign through minus 3x plus 7. And then, as should happen at some point, a lot of stuff in these problems, a lot of stuff will go away. The 3x's will cancel out. The 7's will cancel out. And so now we're left with just 3h in the top and an h in the bottom. So I'm going to write that out here for clarity. The h's, of course, now will finally cancel out, getting rid of the 0 over 0 problem, leaving us with just a limit of the constant 3, which we know is just 3. So the slope of the tangent line to y equals 3x minus 7 is always 3. And that actually shouldn't be too much of a surprise, because 3x minus 7, that's the equation of a line, straight line. And lines always have the same slope. So that line is always 3. So if you pick any point and draw the line that's going in the same direction as the line, then that line should have a slope of 3. So it really makes sense that that does in fact happen. Okay, so we're going to look at some more derivatives in the upcoming videos. They're going to be a little more complicated than this one. This is a good one to kind of start with to get a feel for how this limit definition works.